Hi guys, welcome back to Data Every Day. Today we're looking at a data set of credit card customers, and we have this column that says whether or not the customer has closed their account. So we're going to try to predict the customer attrition, or churn, or basically how if people are leaving the service or not, based on a bunch of features. So let's get into the notebook. I have some standard libraries we're going to use, NumPy and Pandas, and then standard scalar and train test split function from sklearn for preprocessing. And then here are all the models I'm going to use today. I'm just going to fit all 5 of these and then compare the results. So let's go ahead and import those, and we'll load in the data using pandas.readcsv. Now I'll get the file path to the CSV file right up here, copy it, paste it in, and take a look. And we have 23 columns, which goes over the limit which pandas will show at once. I think it's 20. So we get this ... here. And just so that we can see all the columns, I'm going to go into the console and type pandas.setOption max columns, and I'm setting it to none. That way we can see all the columns if we refresh this. Alright, so we can see them all, and you'll notice at the end we have these two with really long column names, and it actually looks like they're the results of a naive Bayes classifier. And in the dataset here, it actually says somewhere, I think if we select all the columns, it says please ignore the last 2 columns. I suggest to rather delete it before doing anything. So we're actually just going to remove these. They are not actually data. I think they're just the results of a classifier. So in addition, we're not going to need this client number feature since it's unique for every customer. So let's go ahead and start preprocessing. So I'm going to make a function that's going to do all our preprocessing called preprocess inputs. And it's going to take in a data frame, and we'll start by creating a copy of the data frame. And then we're going to return x and y, which will be y is what we're trying to predict, fully processed, and x is going to be what we're using to predict y, fully processed as well. So the first step is to split them off. Y will be just the attrition flag column, because that's the that's what we're trying to predict here. I'm going to make a copy of it. And x is going to be everything except the attrition flag. So we're dropping it from axis 1 and making a copy as well. Now if I run this and I call preprocess inputs on the data and I store it in x and y, we can see x is everything except the attrition flag column, and y is just the attrition flag column. Alright, so what if we keep modifying this preprocess inputs function and seeing how it affects x? I think that is what we're going to do. But I'd like to get a little more information about the data before I go further. First, I want to see if we have any missing values. So I'm going to get data.isNA. Will give us the whole data frame, and there will be a true or false value if it will be true if there's a missing value in a given location. So if we sum over the rows, we can get the number of missing values in each column. And you can see there are 0 missing values in every single column. Now these ones at the bottom are really long, but we're going to drop those. So I guess that can be the first thing we do. Let's drop. So I'll just comment it. Drop the last 2 columns. They're unneeded. So df equals df.drop. And I don't want to reference them by name because they're so long, so I'm just going to say df.columns -2 to the end. So these are the last 2 columns, essentially. And I don't need to put this in brackets. And we're dropping from axis 1. Alright, now if we run x, and we run this, and then check x, we should see that those 2 columns are gone. And the last column we have now is the average utilization ratio, which is the one that comes right before them. So we're good to go. Additionally, I'd like to drop the client num. It's called a client num. Drop client num column. Since they're all unique values, client num, dropping from axis 1 as well. Now you can see client num is gone, and those last two are gone. So now we have, I believe this is all the data we'll be using to predict our existing customer or attrited customer. So that's another thing I should do, is check all the unique values in our label column to make sure we only have 2 labels. So that was, I believe it's called attrition flag, right? Just like this. So we're going to check the unique values in the attrition flag column with .unique. So yeah, there's just 2, existing customer and attrited customer. So it will be a binary classification problem. Alright, and then last thing I would like to do in terms of collecting some information is I'd like to see how many unique values are in each categorical column. So I'm going to make a dictionary that maps a column to the length of unique values in the column. I'm getting that from data subcolumn.unique and then taking the length. And that's going to be for every column in, I could do data.columns, but I just want the object columns, the categorical columns. So I'm going to do data.select dtypes object.columns. So just the categorical columns, I'm going to match the column name to the length of unique values in the column. And you can see there are 2 unique values in attrition flag, 2 unique values in gender, 7 in education level, 4 in marital status, 6 in income category, and 4 in card category. So right away we know we're going to at least need 2 different encoding schemes. For the 2 value columns, we can use binary encoding, which is just, I mean, it's a special case of ordinal encoding where we pick one of the values to be 0 and the other to be 1, and that's all it is. It's going to be a 1 or a 0 depending on what the value is. And the other ones, we're going to either use ordinal encoding or one-hot encoding, depending on if their values can be ordered or not. So to get a little more of an understanding, I'm going to change this from length to list. So instead of just giving this the lengths, we're going to get the list of all the actual unique values for each column. Now we can see what kind of values are inside. So for example, education level now, we can see there is probably an ordering between these, and in income category as well, some sort of ordering. However, marital status and card category has no ordering, so these will be one-hot encoded. Alright, so one more thing I noticed upon looking at this is that we have an unknown value here and here and here. And that is essentially a missing value. So instead of giving this its own, like for example, in the education level, we can't really order unknown. Doesn't make sense. So what we'll do is we'll fill the unknowns with the mode of the column in the case of an ordinal column. For this one, marital status, one-hot encoding actually takes care of the missing values already, so we don't have to worry about filling it in. But for education level and income category, which are ordinal, we're going to change unknown to the mode of the column. So let's do that. Here, I'll just comment this, split df into x and y. And then up here, I'm going to, the first step is let's change unknown to actual missing values. So let's encode unknown values as numpy.nan. And to do that, very simply, df equals df.replace. This will find any entries in the whole data frame with the value unknown, and we'll replace it with numpy.nan. So it will be an actual missing value, which we can then use the fillNA function to fill in. So if I run this, and then run this, and this, and this, we can see, we can't see it exactly, but if I check x.isNA, okay, we can see the actual missing values, and there aren't so many. There's about maybe 10% missing values. I think we have 10,000 rows in total. We can get the mean to get the actual percentage. 14% and 10% and 7%. So not too bad. We can definitely just fill these in. But I'm I'm going to note one more time, marital status is a one-hot column, so we're not going to fill those values in. The one-hot encoding will take care of the missing values, as I'll show later. But the education level and income category are ordinal values, ordinal columns, so we're going to fill these. We'll fill these ones with the mode of income category and fill these ones with the mode of education level. So, fill ordinal missing values with modes. And this is just going to be the education level and income category columns. So all we have to do is separately, first for education level, excuse me, it will be equal to itself, but with fill NA, which will fill all the missing values with a given value. The given value here will be the mode. So let's see what that is. If we get the mode of this, oh sorry, it should be data here. It's graduate. So graduate is the mode, and we're going to fill all the missing values with graduate. Then similarly, we're going to do the same thing for income category. So I'm just going to paste in income category, and then the mode of income category is less than 40,000. So I'm going to use that as the mode here. Alright, now if we take a look at the missing values, they have been removed, and we only have missing values in that one-hot column, so we're good to go. Alright, let's actually do the encoding now. So we're going to need all three standard encoding schemes. Let's create some functions to do them. Binary encoding, ordinal encoding, and one-hot encoding. For binary encoding, very simple. To each of these, we're actually going to pass in a data frame. And then for the binary encode, we're going to pass in a positive value as well. So the positive value is going to be which value do we want encoded as 1. The other one that is not the positive value will be encoded as 0. So we'll start, actually I want to do this for all of them. I'm going to start each one off by creating a copy of the data frame so that we are dealing with a fresh copy. And then for binary encode, all we have to do is take the column and apply a lambda function to it that maps a given x, or a given value in the column, to 1 if x is the positive value, and otherwise 0. So it's very simple, it just goes 1 or 0 depending on if x is equal to the positive value that we pass in. Then we'll return df, and that's all we need for a binary encode. For ordinal encode, we're going to pass in ordering. This is the order in which we want to encode it. We're going to pass it in as a list. And then we're just going to take the column and also apply a lambda function to it. But this time, instead of doing this kind of thing, we're actually going to use the ordering, and we're going to index x in the ordering. So since the ordering is already sorted in whichever way we like, if we call index and pass x in, we'll get back the integer index for the value. So each value will go to a mapping to the indices of ordering. And then we can return df. Then for the last one, this one's just a little more complicated. For this, we're going to use pandas.getDummies. So we pass in a column here. Let's get one from data. How about, let's see, card category. We'll use getDummies on card category, and you'll see that each card category gets its own column now. So before they were just oh, that's over here. Before they were just entries, right? But now they're actually columns, and the entries have become 1s and 0s depending on what the given entry was for a given example. So for all the examples that we can see in the preview here, it was blue, and then the last example was silver. So if we go back up to the data, you can see blue, 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 and silver. Alright, and note that we can also include a prefix. How about card? And that will just put the prefix of our choosing at the beginning of each column so that we know where these new one-hot columns were generated from. Alright, so over here in our function, we're going to create these dummies with pandas.getDummies from a given column with a given prefix. And the prefix we're actually going to pass in along with the data frame. So prefix equals prefix. Alright, and now we're going to concatenate with pandas.concat the original data frame and the new dummies columns side by side, so axis 1. And we're going to drop the original column from which we created the dummies. After that, we can return df, and that's it. These are our 3 encoding functions. So now let's do them one by one. Let's start with the binary columns. So, which are our binary columns? It's actually just these two. It's our label column, which we're trying to predict, attrition flag, and our gender column. So, encode binary columns. df equals, and remember each of these return the whole data frame, so I'm saying df equals binary encode, passing in df. The column will be attrition flag, and we're going to pass it a positive value. Attrited customer will be our positive value. So if the customer is still, if they're still an existing customer, they'll have a 0, and if they're an attrited customer or a customer who has quit the service, they will be a 1. And then we're going to do the same thing for the gender column. The positive value here, we'll make it m. This is arbitrary though. And then we will encode the ordinal columns. So, ordinal, there are 2 of them, education level and income category. First we'll do education level. So df equals ordinal encode, df, education level, and we pass in an ordering. So the ordering, actually we need to specify. So I'm going to create something called education ordering. This will just be a list of all the values in education sorted. So I'm going to copy these and let me just get them indented properly. Hold on, let's get all of them. Bring it back here and then indent like that. Alright, now we already dealt with the unknown values, so I'm taking that one out, and we're going to sort it from least education to most education. So uneducated goes first. So I'm putting that here, then high school, then college, then graduate, then postgraduate, then doctorate. So there we go. Then in the ordering here, we're going to pass in education ordering. Alright, now we also want to do this for income. So the column is called income category. So I'm pasting that in here, but this ordering, let's make one called income ordering. And I'll specify that here. Income ordering. And the income ordering is given by these ones. So I'm going to paste that in. Again, we will fix the indenting. And we're getting rid of the unknown value. And let's sort it. So less than 40k comes first, then 40k to 60k, then 60k to 80k, 80k to 120k, and 120 plus. So there we go. Okay. And it looks good. So remember, we're using this function that's going to index a certain value in the ordering. So these are the orderings. If let's say we find an entry that's 80k to 120k, that'll get plugged into the orderings index, and we have 0, 1, 2, 3. So that entry will become 3. And this will take all these categorical entries and turn them into unique integers. Okay, so let's see how this is going so far. I'm going to run. Oh, got multiple values for argument positive value. How is that possible? positive value. How is it getting multiple entries? How does this make sense? Binary encode got multiple values for argument positive value. Here's positive value, and we're just passing in one entry. I mean, one value. Alright, give me 1 sec, I'll figure it out. Okay, I figured it out. I forgot to include a column argument in each of these. We obviously have to specify the column that we want to encode. Okay, so I was referencing column here without passing it in this whole time. Right, so now it should work, that we have the columns, we're passing in the data frame, the column name, and then the positive value. And, oh, did I not run this? Okay, there we go. Now x, here it is. You can see that all of our variables have been encoded as integers. The income category in an ordinal form, education level in an ordinal form, gender in a 1 and 0 form, and then y is just 1s and 0s as well. This is what we're trying to predict, the attrition flag. So the only thing left is now to do the one-hot encoding on the marital status and card category columns. Now here there's missing values, but that's okay, because if we get the dummies for, we'll do x sub marital status. Is that not? Oh, I wrote Marshall. Hold on, marital status. You can see that there's no missing value column. In fact, for an entry with missing values, like the third example, you can see we just have all zeros straight across. So that is essentially dealing with the missing value. We don't have to fill it in or anything. So we have a 1 for whatever value is originally there, but if we have a missing value, it's just all zeros. Alright, so now let's do the, we'll encode nominal columns. Alright, so now we're going to use our one-hot encode function. So all we have to do is say df equals one-hot encode, pass in df, pass in the column name, and there's only two. It is marital status and card category. So for marital status, we have to specify a prefix. How about we can just make it ME, no, MS, marital status. And then the other one is going to be card category, and we'll make the prefix CC. Alright, and let's run it, check it out, and I believe we should have fully numeric data. Here are all of our one-hot columns, 3 of them from the marital status column, 4 of them from the card category column, and then everything else is also numeric. So I believe we are ready to scale and split our data. So I'm going to scale after we make the split here into y and x, because I only want to scale x. I don't want to scale our labels. So scale x with a standard scaler. So I imported standard scaler at the top here from sklearn, and that's going to give each column in x a mean 0 and a variance 1. So let's say we'll make scalar equals standard scaler. So we're making a new scalar, and then x is going to be scalar.fit transform x. So this will take the scalar, will look at x, find how to transform it with fit, and then actually transform it and store it back in x afterwards. I would like to note though that this returns a numpy array instead of a data frame, so I'm going to turn it back into a data frame afterwards and keep the columns the same as they were. So columns equals x.columns. Alright, and now if we take a look, our x has all the same columns, except every column has been scaled to have a mean 0 and variance of 1. So most of the values in each column will lie between -1 and 1. Y still looks the same, and I believe this is ready to get fed into the model. So let us now start training. Our pre-processing is done. So for training, we're going to first make a train test split. So I'm taking x and I'm going to split it into xtrain and xtest. And I'm also going to split y into ytrain and ytest using the train test split function from sklearn. We pass in x and y, specify a train size, I'll do 70%, and a random state just to be sure that we can reproduce the results. This function also shuffles the data, so we don't have to do that ourselves. Alright, we split that. We now have these 4 new sets of the data, and we're going to construct 5 different models, the ones I imported at the top, which are these ones. So I'm just going to paste this in, and I'm going to delete all this from each one. Whoops. Oh no. Okay, here they are. So these are the names of the models. So I'll just create new instances of them for each value. And I'll just indent this one, and I'll put some commas as well. Okay, so this is a list of models, and then what we can say is for model in models, we'll just fit the model on the train set. So model.fit xtrain ytrain. There we go. All 5 of our models should be fit when that completes. And then what we'll do to show the results is we'll create some model names. This will just be a list of the names of each model. So we'll have a logistic regression. We'll have a support vector machine. I'm just making sure this takes the same order as up here. And just for speed, I'll just paste this in from my other notebook. And I indented them so that they all line up. Then for model, comma name, so I'm going to iterate through the models and the names simultaneously using the zip function, which takes 2 lists and pairs them up element-wise into tuples. So we're going to pair up models and model names, and then we can get 2 values at a time. So these 2 will be paired up, then the SVC and support vector machine will be paired up, and so on. And we can iterate through them with model and name. And I'm just going to print out name, so it'll be this one of these things, plus, I'll give it a colon, a space, and then I want to display a float to 4 decimal places, and I'm going to format with model.score xtest ytest. So this will return the accuracy score for a given model, and it'll have its name in the front so we can see. And I want to multiply this by 100 so we can get a percent format and put a percent sign there. And here we go. This is the results. So we can see it looks like the logistic regression. Oh wow, it actually happens to go in ascending order. I didn't mean for that. Random forest performed the best with 95.9% accuracy, whereas logistic regression performed the worst with a 90.5%. So that will sum up today's video. Thank you so much for watching. I hope you enjoyed it. If you did, make sure to subscribe and hit the bell for more content, and leave any comments you have in the section below. I'll see you guys tomorrow. Have a fantastic day.